Let's solve the first problem of Laplace transform, and I have taken this problem from GATE 2006 exam. So let's read the problem. Consider the function ft having Laplace transform fs equal to omega naught over s square plus omega naught square. The final value of ft would be. There are 4 options and we need to choose the correct option. Now as soon as we read final value of ft, we get the idea to use the final value theorem. We have studied the final value theorem and we know the final value of ft, which is f infinity, or we can say limit t tending to infinity time domain signal ft is equal to limit s tending to 0 s multiplied to fs. In this problem we have fs, and if we multiply s to fs we will get sfs, and after applying the limit s tending to 0 we will have the final value of the time domain signal ft. So this is what we can do. But I told you in the lecture of final value theorem that this theorem is only applicable when the 2 conditions are satisfied, and the first condition was ft must be equal to 0 for all the values of t which are less than 0, and we check this condition only when the region of convergence is given. But here you can see region of convergence is not given along with the algebraic Laplace transform, so we consider this particular condition to be true. After this we move to the second condition, which is very important condition. This condition is important because we need to check this condition each and every time we are about to use the final value theorem. According to this condition, SFS must have all the poles on the left hand side of S-plane. So our task is to find the function SFS, and once we have the function SFS we will calculate the poles and then we will plot the poles to find whether all the poles are laying on the left hand side of the S-plane. So let's begin with the step number 1, in which we will calculate SFS. To calculate SFS, we will simply write down Laplace transform fs. It is given in the question that it is equal to omega naught over s square plus omega naught square. Now we will multiply s on both the sides, and in this way we have s omega naught over s square plus omega naught square as the value of SFS. Now to find out the poles, we will equate the denominator with 0. So let's equate the denominator, which is s square plus omega naught square, and we will equate it with 0. And solving this, you will get s is equal to plus minus j omega naught. Now we will draw the S-plane. This is our final step. And in this S-plane, we will locate plus j omega naught and minus j omega naught, because we are having 2 poles, plus j omega naught and minus j omega naught. And you can clearly see that all the poles, this means these 2 poles, are not laying on the left side of the S-plane. Therefore, the second condition is not satisfied. Therefore, we cannot use the final value theorem. Now what we can do to solve this question? To obtain the final value of ft, the first step is to obtain the function ft itself. And we can obtain ft using the inverse Laplace transform. Using the inverse Laplace transform, we can find out ft from fs. But this process is lengthy, and whenever you are about to use the inverse Laplace transform, always recall the basic Laplace transforms we have studied, because when you look at the Laplace transform we are having here, you will find This is the Laplace transform. This is the Laplace transform of sine omega naught t multiplied to ut, which is a basic time domain signal. So in this way, we have time domain signal ft. It is equal to sine omega naught t multiplied to ut. Now to get the final value of ft, we will put t equal to infinity. So we have f infinity equal to sine infinity multiplied to u infinity. We know unit step signal is equal to 1 from 0 to infinity. Therefore, u infinity will be equal to 1, and we know sine infinity is not defined. It is not defined because infinity is not defined, and therefore sine infinity is also not defined. But we know one thing for sure, that sine infinity will have value between -1 and 1, and sine infinity is nothing but our function ft when t is equal to infinity, or we can say the final value of function ft. So in place of sine infinity, we can write f infinity, and f infinity is between -1 and 1, and it can also be equal to -1 and 1. And when you match the 4 options, you will find option C is the correct option. So this is all for this question. In the next lecture, we will deal with another problem of Laplace transform.